Good morning, everyone, and welcome to Vivid. We have a webinar today sponsored by the APM team at HPE. The title for our session today is Proactively Monitor User Experience in a User-Centric Digital World. Next. If you can move the slide, that'd be great. There we go. Again, brought to you by Hewlett Packard Enterprise. Thank you. Next slide. And I'm your host and moderator today. My name is Rocky Pisto. I'm a Vivid leader for a number of chapters, and I am one of the BSM SIG leaders. So along with webinars that we help moderate, we also sponsor a practitioner call in the BSM SIG that we have almost monthly or twice or every couple of months. So be on the lookout for that from us. Next. And today's speaker is Dan Ooster. He's the APM Senior Technical Marketing Manager for Hewlett Packard Enterprise. And with that, Dan, it's yours.
Oh, okay.
We have a couple
things here.
Right, I forgot. So this is a live session being recorded, and the recordings will be available to all Vivid members. So if you couldn't make this live session, you can catch it in the recorded session. We also have the ability to type in questions, and here is the panel. You'll see where it says questions and chat. Feel free to ask any questions. We want to make this thing as interactive as possible, and all these questions will be recorded with the answers so that after the fact, if there's something you missed, it'll show up in the recording. We send all of this back to HPE to answer, if you can, to address your questions. So feel free to make it as interactive as possible. Next. Now it's yours.
Now it's mine. Okay, so hi everybody. I'm Dan Ooster. I'm the HP Technical Marketing Manager for APM. And today we'll focus on RUM, predictive analytics, and service level management, and how to manage the user experience with them. So a quick review of the agenda. We will recap at a high level our APM solution. We've covered in previous webinars BPM and SiteScope. We will review once more what they do, and then we'll reintroduce RUM and some of its new monitoring capabilities to be released in the next version. We will also review the health, the application health and its troubleshooting capabilities. We'll also cover Service Health Analyzer and touch on service level management and its new interface. We will also talk about our vision for APM into the future, and then we'll close the Q&A session. Because we're presenting actually a number of things that have not yet been released, I need to actually pass you through the following two slides and to read them to you. So this is a forward-looking statement. This document contains forward-looking statements regarding future operations, product development, product capabilities, and availability dates. This information is subject to substantial uncertainties and is subject to change at any time without prior notification. Statements contained in this document concerning these matters only reflect Hewlett Packard Enterprise predictions or expectations as of the date of this document, and actual results and future plans of Hewlett Packard Enterprise may differ significantly as a result of, among other things, changes in product strategy resulting from technological, internal corporate, market, and other changes. This is not a commitment to deliver any material, code, or functionality and should not be relied upon in making purchasing decisions. And the second slide, which says this is an HP confidential information. And this roadmap contains Hewlett-Packard Enterprise confidential information. If you have a valid confidential disclosure agreement with Hewlett-Packard Enterprise, disclosure of the roadmap is subject to that CDA. If not, it is subject to the following terms. For a period of 3 years after the date of disclosure, you may use the roadmap solely for the purposes of evaluating purchases decisions from Hewlett-Packard Enterprise and use a reasonable standard of care to prevent disclosures. You will not disclose the content of the roadmap to any third party unless it becomes publicly known, rightfully received by you from a third party without duty of confidentiality, or disclosed with Hewlett-Packard Enterprise's prior written approval. So that was a mouthful. We're done with that part. So now we can get into the more interesting things. So let's talk a little bit about a little bit about the background for our monitoring solutions. So I'm going to try and share with you a few interesting numbers. So we have talked in the past webinars about what mobile users expect and how the HPE Apple suite tries to help. So what is true for mobile users is also true for any other user experience that end users want to have today. The expectation of those end users is indeed very, very high. They expect instant gratification. It's the new normal. People expect to get whatever they want immediately, regardless of their choice of technology, location, or context, and regardless whether they're using a web app, a mobile app, a desktop app, or a mission-critical application at work. If they don't get what they expect, there will be consequences. The recent app usage and abandonment study shows that the subpar user experience affects not only the success of the application itself, but also the brand and the business. Just looking at a couple of numbers, when a mobile application runs slowly, 48% uninstall the application and 32% look for an alternative elsewhere. If an application is problematic, 80% will abandon it after 3 attempts or fewer. 69% say application issues gave them a lower opinion of the company that created that application. DevOps teams understand the importance of prioritizing the user experience, but all too often they don't have the right tools to achieve that superior user experience. According to Dimensional Research in the DevOps Application Performance Monitoring, APM, and User Experience Survey, 53% of developers do not have full access to APM tools, 57% lack user experience dashboard, and 61% are blind to the end-to-end process. So that sort of gives you an idea of the picture of the end user experience in the marketplace and in the industry, and sort of the lack of tools that people experience. Here are a couple more numbers. So few application teams are proactive. So quite a few teams will not have what it needs to actually examine the user experience metrics. So only 26% are actually able to do that. A very, almost 3/4 of the application operations team will find out about the user experience problem when the users actually call in. It's what we call monitoring by the end users. And about 40% will actually release the application into production without actually having tested all the user experience criteria. So they don't always meet those criteria. So let's take a look now and see what are the main issues that we want to introduce on the application performance management side. We like to call those the VIP. Treat your application like a VIP. Visualize, isolate, and predict. So when a strategy and solution is in place for managing your business application, you should expect usually the following outcomes. You would like to experience a reduced MTTR. A solution should result in faster isolation and repair of issues. You should be able to keep your customers happy with a very low abandonment rate. And finally, you should have the ability to prevent outages that affect users and implicitly lower your IT support costs. So what do we mean by visualize? Okay, so let me suggest the capabilities you need in order to get to that desired state. You need a single solution that will allow you to visualize the performance and availability of your applications across any application type, across both real user and proactive monitoring, or what we call synthetic monitoring. And you need to have 360-degree end-to-end view that integrates the user experience health and the infrastructure health. In terms of isolation, you want to be able to combat the complexity that contributes to long problem isolation time. And for that, you need to be able to isolate to a specific application version, device, or carrier. You need to be able to isolate to specific user flows, including sort of the line of code at which a problem may occur. And you need to be to isolate it to a specific third-party service to the extent that you're using third-party services. Finally, you may also need a solution capable of alerting you to anomalies based on advanced predictive analytics. You don't want to rely on manually setting threshold for every aspect of your application performance. The threshold setting is a manual effort, and despite your best intention, you may not catch all the issues early enough. You may also get at times false alerts, especially if your thresholds are wrong. So what you really want is to be warned of potential outages before they happen and alerted to issues like unexpected drops in transaction volumes based on user behavior or drastically changing performance after an application upgrade. This will help you prevent outages by recognizing issues as early as possible, hopefully before they cause a business impact. Now, when we look at how applications are provisioned, actually, you have your traditional on-prem application. Some of them are deployed in the private cloud, in managed cloud, in public cloud. So you need a solution that's able to handle all of those. And with HPE APM, we can monitor any type of application. As a matter of fact, we believe that it's going to be a hybrid world out there, a journey to where the enterprise leverages the best of the private cloud, the managed cloud, the public cloud, as well as your traditional IT. HPE recently conducted a survey, and in that survey, about 75% of IT executives plan to pursue a hybrid delivery model. About 72% said that the portability of workloads between cloud models are important to their cloud implementations. And finally, about 65% are concerned with vendor locking. Why do we believe, and clearly most IT executives believe, a hybrid model is the best forward way to go? Because a hybrid approach provides the means to address the IT service delivery challenges facing IT organizations today in the most effective and cost-efficient way. This means that taking advantage of the capabilities, things like service level agreement, availability, security, performance, compliance, cost, offered across the private cloud, managed cloud, and public cloud, as well as traditional IT. It means also looking at the portfolio of applications in your organization, segmenting them according to their respective SLA requirement, and then aligning to the application to the appropriate deployment model, and thus creating the most optimal use of internal and external resources. In this new hybrid world, the role of the CIO in the IT organization expands from the traditional builder of services to a built-in broker, creating a seamless experience for end users independent of the service source. And you also need an APM toolset that can handle this brave new hybrid world. So let's go now and answer a couple of polls. Rocky, can you present the polls, please?
Yes. Sure. So the poll is up, Dan, and the question is, what is your primary concern with your applications? And please just pick one. So the first one's availability, performance, number of customers affected, business impact, in other words, in dollars, and customer perception. So these are the 5 potential answers you can click on to determine what's your concern around your applications. And then while people are making their choices, we had a couple of great questions around ALM customer not having the ability to check the performance or monitors of their application, and the answer to some of this stuff, especially with the other question was performance center and load runner, they just can't perform these kind of tests with ALM. So the answer is that in those situations, RUM monitor, real user experience type monitors can be used, SiteScope, BPM. So we're going to be talking about some of these tools, and again, they can definitely be leveraged. So let's get the results, Terry, and let's see where they come in. So, wow, the results are in, and the highest concern for customer applications is performance at 57%. Then we've got availability at 14%. Number of customers affected is 10. Customer perception is 14, and business impact is 5. So that kind of gives you a feel, Dan, of the audience and their concern with their applications.
Okay, this is actually very interesting. It's actually more or less in sync with what our understanding is of the concerns. It used to be that application availability was a much higher percentage, but over the last few years with high availability, with concurrent applications and the ability to run with multiple data centers and so on, this has decreased significantly. So at this point, yes, performance seems to be indeed the highest concern. So that just matches with what our understanding is. Okay. Do we have another survey question to run there?
We do. We just popped up. And this particular question refers to which of the following APM tools do you use today? One or more. So you can, if you've got them all, you can check them all. And the first one's BPM, RUM, Diagnostics, SiteScope, and then the final is other third-party tools. So that would be interesting to know what APM tools are out there. So, you know, I've been in this space for the last 23 years since OpenView was actually offered to the channel, but I'm interested in learning a lot about the new functionality of the APM suite so that we can kind of share with our members. So that'll be great. So, Terry, let's see what we've got. Here we go. So, yeah, kind of what I assumed, you know, in some cases, BPM, 58%, which is the synthetic transaction monitoring, which a lot of us use. RUM is at 37%. That's pretty interesting. Diagnostics, about 37%. And obviously the big winners are going to be SiteScope, which a lot of folks had from a monitoring perspective and leveraging that functionality. And another one is 63% are using third-party tools. So and it looks like based on all the percentages, which exceeds 100%, is that there's a combination of tools being used to monitor in our member environments.
Great. Okay. Thank you very much, Rocky. Okay, so we did run through 2 of our surveys. So what we're going to do next is we're going to start diving into APM, and we're going to go through a quick overview. So question is, what is APM? Okay, and we look at it as the gaining the 360-degree visibility into the health of the end-to-end business services for all types of applications and infrastructure. Also managing the performance and availability of web and mobile application. It's a place where we want to have a single pane of glass across any applications, top-down monitoring and domain manager for APM, basically looking at tools like BPM, RUM, diagnostics, SiteScope, service health analyzer, service level management, where each tool contributes to the visibility by contributing a level of details into that application. That's what we call it the 360-degree views, because each one of the tools provides additional levels of details. So on the left side, you have the end user experience that's comprised of two different tools, the business process monitor, which is a synthetic monitor. We also sometimes call it a proactive monitor, and the real user monitor, which monitors basically what the real user does, and we'll go over those tools into a little bit more detail in a minute. And then on the back end, we have what we call the back end traceability, where we have SiteScope and diagnostics. SiteScope looks at things like infrastructure, services, various counters for them, how they're performing, and diagnostics looks at the deep level probing and how the transaction is traversing the infrastructure and where it may encounter some of the delays. From an end-to-end application health, we look at all the data collectors that monitor the solutions from all those monitoring solutions that send the data to APM, and then we consolidate all this information to understand the end-to-end health of the application. The top-down business view, it monitors, measures, and manages your application according to the impact of the business and your established SLA. Now, when we say a top-down business view, it means that we look at the at your application starting from the application perspective with all the underlying supporting services all the way down to the supporting infrastructure. However, we start from the application level, which is the top, going down into the infrastructure. We also look at it from the perspective of the bottoms up, which means starting from the infrastructure, we then try to understand what a particular piece of infrastructure affects or which application or which services may be affected through the failure or unavailability of any one piece of infrastructure, and that's the bottoms up approach. And both of those are actually enabled by the ability to create an application model in the runtime service model we call the RTSM. And the runtime service model is just an internal component of APM, which is based on the configuration management database, on the universal configuration management database, which is the HPE offering. Now, in addition to that, from an end-to-end application health, we also want to understand what are all the locations that are affected, what are the business transactions that are affected, how many users are affected, which users are affected, and to understand also the impact on service level contracts. And so that's sort of the high-level view of what end-to-end application health means. So let's go now to the various monitors one by one. We're going to go through a very quick overview or recap of some of the things that we've talked in previous sessions. And I want to remind you that we've had so far 4 Vivid sessions. We've talked in 2 of them about Apples, in 2 of them about APM. So what I'm trying to do in this 4th session is to also bring all that information back together with a short recap and summarizing it at the very end.
Dan, I can just add that all the webinars are recorded so that they can go back and find them on the Vivid website.
Great, thank you, Rocky. Very good point. So the other reason I'm also trying to do the short recap is so that we can compare and contrast. So I'll start with a BPM. What is the BPM? So the BPM is a end user monitor. It is agentless. It's using the leading testing technology for HPE. It has a large number of protocols. Those of you that come from the testing world may be familiar with load runner. So we're using very similar protocols, almost the same protocols, the same scripting technology. And as you can see at a glance, the HPE Business Process Monitor software proactively measures the end user experience by executing controlled, repeatable transactions from multiple locations. And those locations can be inside or outside your firewall. And they're trying to identify the availability and the performance issues before they impact your customer. You can view your web, mobile, and traditional application the way your user experience them, basically. How long is it taking to log in, to look up an item in a catalog, to complete a purchase? Think about something that you might be doing, for example, on Amazon. You can also monitor external cloud-based services your business depends on from performance and availability. As a matter of fact, BPM is completely agnostic to the deployment type of your application. As long as it has a web-facing view, we can actually monitor that web-facing application, whether it's in the cloud or on-prem. Basically, how does it work? Well, the BPM executes scripts that are recorded with the HPE Virtual User Generator, or what we also call VueGen. Those are basically the transactions that simulate the complex business processes in your application. It is similar to having actually a real user access to that application. And what we do is record that interaction of a user. And usually we record what we expect that user to do. So the test script that we run to the BPM are sort of that expectations, are based on the expectations of the interaction between the user and the application. When users interact with the application, their actions involve a set of requests. Those requests traverse technology components such as firewall switches and load balancers, web servers, application servers, databases, mainframe. And this request generates a response which BPM first validates for accuracy. The monitor then captures the response time and the availability metrics. And BPM allows you also to emulate even the most complex transactions. The same scripts that you use today using Loader in the QA environment can also be ported over to the monitoring side. Of course, where on the testing side you're trying to break an application, that's the last thing that you want to do in production. So the intensity at which you monitor usually is something that would not go over 1 or 2% of the load, and that's sort of where the difference is between what we do on the QA side and what we do on the monitoring side. The other thing to remember is that if it's important enough to test in pre-production, it should be just as important to monitor in production. Then the BPM sends the availability and the performance data to HPE APM console, where we do the reporting in the real-time, we have the real-time visibility. And you can also manage your BPM from the console, including tasks such as setting alerts, thresholds, and managing scripts. So in a nutshell, you can think of the BPM as being a three-step process: record, replay, and review. So you record with VueGen or with TrueClient. We replay it from a number of different locations around the world, including in your data center. And finally, once we collect all the data, we review the data in the console. In terms of dashboards, reports, we can generate alerts, and we can monitor the service level agreements. A very quick review here of the various protocols, and I'm not going to go over every single one of them. Is just we've classified it in terms of mobile, web, Oracle, databases. So there is a number of different protocols that the BPM supports, and this should give you an idea that pretty much any application that is user-facing can, in principle, be tested with a BPM. So let's now take a quick look at what SiteScope represents. So SiteScope is basically an agentless monitor. It connects over the network, and then on a sampling basis, every anywhere from 5 to 15 minutes, it goes to the servers that you have configured and collects a variety of different metrics. There are over 150 monitors that are available with SiteScope. One SiteScope server can monitor hundreds, if not thousands, of remote servers. We can deploy SiteScope both in on-prem as well as in the cloud, and we can monitor with SiteScope both physical as well as virtual environment. And when we talk about virtual environment, we're talking about both virtual machines as well as Docker containers, and we'll touch on that in a couple of minutes as well. SiteScope is extremely easy to install. It takes roughly about 9 minutes to install. It may take a little bit more time to configure, if you have thousands of servers. But if you do have thousands of servers, we make it a lot easier for you to configure those servers by providing a rich set of templates. So if you have 100, let's say, Linux servers, you can apply the Linux template, and then all of those will be monitored with the same, producing the same counters across all your Linux monitors. Same things holds true for Windows, Oracle, Exchange, and so on. There is a good number of templates available. SiteScope also provides an integration platform with third parties, as well as it can integrate into the HPE Operations Bridge and APM. And it also has a user experience that's available both on your desktop as well as on mobile devices, tablets, iPhone, Android devices, and so on. So that's what SiteScope is. How does it work? Well, on the bottom, you can look at the components basically that SiteScope can monitor, and so it can monitor firewalls, network devices, virtual and physical servers, application servers, databases. And on the top is the way that information can be consumed. So it can be consumed in terms of reports, alerts on dashboards, in the unified console, which can provide you a hierarchical view of your monitored devices and the metrics. You can configure your users and administrators. You can provide integrations, and you can also display it on mobile devices. So the way to think about SiteScope is that it's a very simple monitor to install. There is nothing really to install at the resource to be monitored. We define everything remotely and only access it at execution time. Now, let's also take a look at the monitors, and I'm not going to go over every single one of them. Again, we structure them for you in terms of classes of monitor, things like server, network, web, integration monitors, application monitors, and so on. But this from this list is quite an exhaustive list. So BPM and SiteScope are two of the things that we've talked about in the past. I wanted you to see actually what BPM can do in terms of the various the availability of the various monitoring protocols. Same thing for SiteScope, and I'm going to drill of SiteScope, and the reason I'm doing that with SiteScope is because then we're going to go through something that we haven't talked in the past Vivid webinar, which is the the RUM monitor, you'll see that RUM also can complement what SiteScope can do on the monitor side with some of the virtualization and Docker monitors, and can also complement what the BPM can do in terms of the various protocols that it monitors, a lot of those capabilities. And that's where that compare and contrast that I started with comes into the picture. So before we can see what SiteScope or RUM can do with Docker, let's review very quickly what Docker is. So we said SiteScope can monitor Docker, but what is Docker? So Docker is an open source project that automates the deployment of application inside software containers. A Docker container wraps up a piece of software in a complete file system that contains everything is needed to run. That contains the code, the runtime environment, the system tools, system libraries, anything you can install on a server. But not more than what that particular application requires. So this guarantees that it will always run the same way regardless of the environment it is running in, because everything is packaged together. And Docker provides also an additional layer of abstraction and automation of operating system level virtualization on Linux boxes. There are efforts to port or to provide Docker containers also in Windows and in Mac operating systems, but it's not yet there. Now, Docker also uses the resource isolation features of the Linux kernel, and in terms of technicalese, we think of those things as the C groups and the kernel namespaces, also union-capable file systems such as AUFS and others to allow independent containers to run all within a single Linux instance. And this avoids the overhead of starting and maintaining a virtual machine. So a container can be tens to maybe hundreds of megabytes in size. A virtual machine is usually gigabytes to tens, sometimes hundreds of gigabytes in size. So we're talking about orders of magnitude in difference. So that's why Docker is a much lighter virtualization mechanism. However, don't think of Docker as just being yet another virtualization mechanism. Docker is something that provides all the abstractions required to run microservices efficiently. And those allow now for the low and capacity base flexing in and out. Okay, so in order to port things to Docker, you really need to think of it as re-architecting your application. Yes, you can just drop it, an application, a Docker container, but you really want to re-architect them and run them in a much more efficient fashion. So we talked about what Docker is. Let's look also at how Docker is organized. So you can see here in terms of containers and workloads, so that's sort of your basic unit, okay? So a container is basically the workload, it's the application with all the required services. Now, on a host, I can have a Docker service. The Docker service can manage multiple containers or multiple workloads. And finally, I can have multiple nodes being part of a Docker cluster. The cluster is managed by a cluster manager, so you can have a cluster manager managing multiple nodes. Each node can contain multiple containers, and those containers can flex in and out, and also can transition from one node to another. All that is done, or all of that is managed by this cluster manager. So those are this is the hierarchy of what a Docker cluster looks like. Let's look now at where SiteScope comes into the picture in terms of the Docker monitoring, and then we'll eventually contrast them also with how RUM is able to manage Docker or monitor Docker. So here on the left you have your SiteScope server, and then on the right you have the Docker environment with Docker cluster with multiple nodes, each node running multiple containers. So at the cluster manager level, we look at we collect data about the health of the cluster management service, things like availability and configuration. At the host level, we collect data on the health of each host in the cluster, basically the system metrics. At the Docker service level, we collect the health of the Docker service on each host, so system metrics, availability, the configuration. At the container level, we get the health of each container around the cluster, again, system metrics, availability, and configuration. And at the application, we detect the health of the application running inside the container, so whatever specific metrics for that we have for that specific application type. Okay, so we talked so far about SiteScope and BPM, things that we've also looked in the past that are part of the APM solution. Let's look now at the third component of this APM solution, which is RUM. Okay, now RUM stands for Real User Monitor, and we like to think about it as collecting data about all the users, all devices at all locations. The best way to think about RUM is sort of an application-aware network-level sniffer. Okay, it can be configured to detect specific applications or pages in an application, user transaction, things like streaming and session-oriented protocols. It can collect the complete user session. And it also has built-in high-level security. So it has hardened probes and engines. It has non-addressable probes, so the probes are not addressable by an IP address from the environment it is monitoring. And it can handle sensitive information. It can either hide the sensitive information or simply mask it and not collect it at all. Okay. In the picture here, you can see that we have the RUM probe and the RUM engine. The RUM probe can collect data from the network. However, the best way to think about the RUM probe is to think of it as being either a physical or a virtual collector. So in a physical environment, we can install the RUM probe to collect data from the physical network. In a virtual environment, we can actually install the RUM probe to go into the in the physical environment, and we deploy the probe onto those virtual networks, whether those virtual networks are in a virtual machine or in a Docker container cluster. The other thing also is that unlike the BPM, which are distributed across the world wherever the users are located, the RUM probes are installed in close proximity to the server and the applications they are monitoring. And because of their location and because of what they do, they're sniffing the information of the network. The RUM probe can actually see all the users that are coming in, because they see all the requests, they see all the responses coming from the servers, and as they copy the user, as they copy the requests coming from the network and the responses coming from the servers, the RUM probe and the RUM engine can actually generate a good picture of that user session. The difference between the RUM probe and the RUM engine is sort of a hierarchical organization. The RUM probe is basically the sensor, is what we deploy either on the physical or the virtual network. The RUM engine is where all the data from many RUM probes is collected. The RUM engine can send summarized information over to APM, and depending on the complexity of your network and the number of networks and so on, you can have multiple probes connected to a RUM engine, and then multiple RUM engines connecting to the APM console. Okay, so we can actually handle very large deployments. The other thing also I want to mention is that because the RUM probe collects data from the network, again, virtual or physical, it collects data not only from the incoming request of the users, but it can also collect data that travels on the network between application, so the data that goes between the web server and the application server, between the application server and the databases. And as a result, RUM can understand HTTP-based application, the various other protocols that travel on the network, like the protocol between the application server and the database, Oracle protocols, MS SQL protocols, and so on. Okay, so we talked about what RUM is. Here is a very quick overview of the protocols that are supported by RUM. Again, broken down by the various categories: HTTP, SOA, mail protocols, databases, generically supported protocols. Notice also that we support both session-oriented protocol, things like IMAP and HTTP and SOAP in some cases, as well as streaming protocols like RDP and, for example, SSH. So there are a variety of different types of protocols that we can collect. We can also detect things like various financial protocols as well. Now, going into HPE RUM for Docker. So the RUM probe, the RUM monitor for Docker is very, very easy to configure. As a matter of fact, we'll see that in a second. All that's needed is an IP address and a port. It's cluster ready, so it does understand clusters specifically for Docker. There are the two most popular cluster managers are Swarm and Kubernetes, and we support both. Once the RUM probe once RUM has been installed and connected to either a cluster manager or to a Docker engine, it will do actually automatic tier discovery. So it will discover whether it's a database tier or a general web tier and so on. And then because we said before that Docker has the ability to start and stop containers very efficiently, so it can bring a lot of containers up or down in a short period of time. It's very dynamic. RUM also has the ability or the capability of automatically detecting new containers. So I don't need to configure the containers. As containers go up and down, RUM will detect them. It has also advanced filtering capabilities. I can actually specify what type of containers I want to look for, whether they're, let's say, HTTP or SQL containers, and so on. And finally, it has the ability to report on all the information that it has detected. So let's take a quick look at how RUM would work with a Docker engine. So the initial configuration is basically one where we connect the RUM probe to a Docker engine, and for that we just have to provide a user the IP port of the host, and obviously the port number. And as a result of that, RUM will automatically deploy the sniffer probe to that host through the connection to the Docker engine, to the REST API to the Docker engine. It will discover the containers, and then it will start monitoring the load balancer container in that deployment. Through that, it will discover the various backend tiers like web and databases, and once it has all that, it starts monitoring the entire application. If new containers are coming and going within that Docker engine host, they will also be detected and they will be monitored. And the other thing we'll see in a second is also the RUM monitor can also detect the topology of the Docker container. So as I mentioned before, we have this load balancing layer. From the load balancing layer, maybe go to an application service layer and to a database, so we can detect that topology. And because we understand that topology and the direction, the flow direction, we can also then do relatively easy isolation. I'll try and show you that in a quick demo. If we're connecting to Docker cluster, the same principle applies. We connect to the cluster manager, again, port IP and port, and from the cluster manager, then the RUM monitor can detect what are the clusters and the nodes, and then deploy probes to each one of the nodes, which in turn will also start monitoring the Docker engine on those nodes. Once the sniffer have been deployed, the detection becomes pretty much automatic, and all new containers can be detected at that point. So if we look at it now from the perspective of the operations, the main thing that we need to provide here is this first predefined layer. Okay, once we define the first component, which is really what we provide when we provide the port and the IP. From there on, Docker will start discovering the layer. So here it's first discovering the general web tier. Next, it's discovering some second level tier servers or tier containers, and finally, it seems to be discovering, in this case, an MySQL set of containers. Okay, so all those backend tiers get discovered automatically. The same way we discover the tiers, we also discover the containers. I mentioned that before that we discover the containers. I wanted you to just get this visual picture. So in the first picture we have at layer number 3, we have here 2 and 2 containers connecting to the containers below. Suddenly a third container may appear here at this layer, maybe because we're flexing out due to capacity requirements. A new container comes in, and then again here we have a couple more containers come in. RUM will detect those and will show those in the topology. And by the way, what you're seeing here is sort of the topology as you would see it in the application itself. Once I see the application, or once I see the containers and the topology of the containers, I can also go to a deeper level of reporting, so I can actually get the information, as you see here on the right-hand side of the Docker host, and underneath that particular Docker host, all the containers, the availability and performance, and the hits on each containers, and so on. So I get a lot of metrics for the containers and the topology. I try to build so far a picture of what RUM can do, so I want to go now to a sort of a troubleshooting scenario for how RUM could be used to troubleshoot an application by showing you actually a kind of an end-to-end scenario here. So here's what we're going to do for this demo. Okay, so we're going to start in the APM, the application health dashboard. We're going to identify then an application with critical availability. We're going to drill down into the application overview, and then from that level, we're going to drill down into the failures for that application. From the failure, we're going to look at the error log. We're going to look for the issues that are presenting themselves in the error log. We're going to try to identify the action associated with the response that caused the issue. I mean, the issue could be a failure, could be a server problem, whatever the problem is, we're trying to detect that. We're going to, from that response, we're going to actually go and look at the actual session itself, the session that was captured by RUM, try to identify from there which action within that session is the one that's failing. And then knowing that this is an application that's supported in a Docker environment, we're going to go back to the infrastructure. We're going to drill into the Docker infrastructure and try to identify within that topology which one is the container that's failing. And at this point here, we're going to stop at the container level, because once we've identified the container, that's probably where we pass that issue back to the to R&D. Now, the thing also to understand is that the reason this will be very very helpful is because we don't have just 1 or 2 servers with 3 or 4 containers running in a data center. If you subscribe to the Docker container technology, you will be having probably tens or hundreds of servers. Each server could have tens or hundreds of containers. So very quickly you get to some real numbers there, and trying to identify where a container resides, what's that container, and what server it's residing on can become very, very difficult. That's what we're trying to solve for you here. So let's start now in the with APM. We're going to start. Those of you that may be familiar with APM and the UI of APM, or what used to be called in the past BSM, will recognize here the application top level, the menu of features in APM, and we're going to drill down to the application health. Within application health, we have a number of different applications that are being monitored. And we see here 2 applications that seem to have some problems. Okay, in this case, we see that we have critical availability for this Docker multi-tier SiteScope application. On the bottom layer here, what we're presenting here is basically the availability, performance, and infrastructure or systems health. This is data that's can be brought in by BPM, by RUM, and by SiteScope. So the infrastructure here would be data that would be brought in by SiteScope if SiteScope was connected. If I look also at the performance, I can see that the performance is good. Okay. However, availability had some issues. So I'm going to drill down into the availability issues. Notice here that I'm looking at the RUM data, okay, and I have information here provided for average availability, average response times, number of failures, and the total user volume. And then on the left, those are the averages. On the right side in the diagram itself, I can actually look at the availability curve, at the volume curve, at the number of failures, and so on. So I see here that I have a pretty large number of failures. I'm going to drill into this number 290 number of failures, pretty high number. And at this point, I drill down into the RUM reporting for availability. I can see here that I have a number of requests not found. Responses. I'll drill down into this request not found, and here I can see all the various failures as they occur. Now here this is also the event details, so I got the status code 404, so it seems like we've gone to a page that this does not exist. I can drill down into the session itself. Okay, so here is the session data that we've collected. Okay, so we notice here that at some point the person was logging in. Here is the user ID and the password. Note that the password is actually masked out. The time at which each one of those requests was occurring, the application, and to the extent that I got an event. And indeed, I did get an event right here, a request not found. Okay, and also to the extent that there were some performance issues, I can also see them here because I can see the total amount of time, the server request, network time. So I get also a breakdown, also various times spent on the network, as well as the total traffic for that particular request. In this particular case, I have 8.2 kilobytes. I'll go back now to the to the application, try also to look at what's the volume sessions that have been impacted. And as I look at this, I notice here that I had a like those 290 failures. They're coming from a variety of different web browsers. So I can see here that I get a large number of users coming through Chrome. Some are coming through Internet Explorer. Some Netscape 9.1, IE8, Firefox, and so on. So all the distribution of the web browsers to which users have come in. And this could actually be interesting from the perspective of what are the most common browsers for my applications that I should be doing my testing for. Because many times the way the applications are built, they have some browser-specific features built into them. Okay, so I want to know what are the most common browsers that I should test for. The next thing I'm going to do also is I'm going to look at what are the operating systems to which people are running their browser. So here I can see that most of the sessions are coming from Windows. I have some from Windows Phone, some that I don't know what they might be, and finally there are some also that are coming through a Mac application. So again, from a QA perspective, this gives me some really good information as to how people are running their the application on the end user side. I can also look at information, I'm not going to go there right now, but also by username. So I can also identify who the specific users using the application. I can look also at stickiness issues as to which users actually have spent the most time on the various pages. I can also look at the most popular actions. So here I can see what are the actions with the most hits. And why is that important when I actually look at my application is because those are the actions that most likely I would like to be able to optimize. So from a business perspective, I want to make sure that the actions that actually are hitting my site the most are the ones that are actually the most effective and efficient in terms of how they're implemented. So if I need to go and do any work on my browser or my applications, those are some of the places where I would want to start. Now, this was sort of a side trip to give you some idea of what are some of the other capabilities of RUM are. I'm going to go back now to our problem isolations. So I'm going to go now to the application infrastructure. And remember that our application was deployed in a containerized environment. Here I can see that I have a number of different tiers that have been auto-discovered by the Docker monitor. So I can also expand this, the general web layer. At this point I can see all the servers on which I have Docker containers running. And the next thing, I'm going to actually drill down into the Docker infrastructure itself. Okay, so here now I can see for my particular application what is the topology deployment of my Docker containers. You can see here that I'm coming in through the APP RP01 to 02 to Cyclope 05. Okay, so this is the flow that actually is running into problems. That's what this red cross means. Those are the ones where the errors are being detected. I'm going to also now try to identify now which layers those containers belong. So I'm going to click on the layer icon, and here I can see now that I have things in the load balancing layer, in the general discovered web layer, and finally in the MS-SQL layer. It doesn't look at this point that any of my problems are in the SQL layer. They're all in this general web layer. And what I want to do next is actually go and look at a little more detail, okay? And I want to understand what are the servers and what are the sort of the metrics that I've collected from there. I'm going a little bit deeper into my investigation. I'm going to expand the Docker engine information here. And now I can see actually all my containers, as well as in the application level here in this list of containers, I can find my SiteScope 005. I can see here that it has an availability of only 90%. And if I actually click the server itself, okay, I have it automatically identified in my list. So as I click on a particular container, in synchronicity with it, I can also identify it in the list and get all the information about availability, number of actions, and so on. So what this has allowed me to do so far is to identify what's the ultimate culprit. What I see here in the load balancing layer and in the previous layer of containers, those are sort of the effects of one of the containers here failing. I don't know yet what the container problem is, but that's sort of an issue that gets I can direct now R&D to that particular container, and they can solve it from there. So this is what I was able to do in terms of isolating the problem to a specific Docker container. And to the extent that some of the capabilities that we have with SiteScope in terms of SiteScope monitoring containers, this is sort of yet again going on that 360 degree. We can provide you information with SiteScope about the Docker containers. We provide you some additional information with the RUM about those Docker containers, and we build this full picture of your APM application. Now, I want to also switch now gears and spend a couple of minutes on predictive analytics. Okay, what's predictive analytics? Well, in APM, we look at predictive analytics. There's a component of APM called Service Health Analyzer, which can detect problems on your behalf anywhere from 30 minutes to an hour and a half before a problem occurs. So I'll go into a little bit more detail on how that works, but let's take a quick look at how do I identify a problem. Okay, so in this case, an anomaly was detected by SHA. There's an anomaly detection panel in SHA, so I've skipped through that. I'm drill down directly into one of those anomalies. I collect a number of different measurements with SHA. I'm also making use of a number of different integrations. So to the extent that I integrate with change management, I will be able to tell when changes have occurred. To the extent that I'm integrating with things like Service Manager, I can also detect when issues have been reported and incidents have been reported in Service Manager. If RUM is integrated, I can also detect the user impact, how many users are impacted. When I have the BPM data, I can also detect the locations users are coming from. If I have service level management configured, I can also detect again the business impact on the application. So here are a number of different things that are displayed on this, are summarized on this detected anomaly. Here is the application service that has been affected. Here is my Advantage Banking application. The anomaly that I've detected affects 89 users. That's about 83% of the users in my environment. I have a service level agreement that has been exceeded, so there is some business impact here. The locations from which I'm seeing are New York, Singapore, London, and Paris. Okay. The interesting thing now, though, however, is that SHA, as it runs through its analysis, provides you with directly with the root cause. So here it already tells me there is a database issues, I have an incorrect database server memory configuration, and this is causing the high swap rate. So this is directly the root cause that SHA has identified, brings it to the forefront, so I can take it as it is, or I can do some additional investigation into it, and we'll do that in a second. But it also tells me whether there are any related items. It also tells me whether this pattern for this root cause, what are those pattern details? So I could go and investigate look at the pattern details, and I can also see whether there are other things that have occurred in the past which may have which displays similarity to my current anomaly, and also how many times or when a similar anomaly has occurred. So here I have two different occurrences, okay, and one is a similarity of 91%, which is most likely very, very similar to this one, and another one which was only about 78% similarity. Okay, so we saw that SHA has been able to detect the root cause, and of course most of you now that are not familiar with SHA will go, okay, so how does it do it? First of all, we use the word anomaly. So an anomaly is not yet an event, is not yet a problem. It's just something that we've detected that does not look right. Okay, and how do we do that? Remember that in APM we collect data from a variety of different metrics, from SiteScope, from BPM, from RUM, diagnostics, if you have any other integrations in there. And as we collect all those metrics, we're able to define a baseline for the metrics. What is normal behavior for metrics? Normal behavior means what's normal behavior at 8 a.m. on a Monday, or what's normal behavior on the last day of the month. Okay, and then if we see a metric coming in that falls outside that sleeve of expected behavior, and we calculate that sleeve basically by calculating an average and then taking a couple of standard deviation from the average. That becomes then our sleeve of expected behavior. Anything that falls outside that sleeve is something that is not normal, it's abnormal. And then we say, okay, well, if I have only one metric that's abnormal, that's not a big deal because that could happen, for a variety of different reasons, okay, noise or whatever. However, SHA out of the box looks at a minimum of 4 such system metrics. So it finds 4 metrics that are all out of their normal behavior band, okay? Then it sort of declares that an anomaly is in progress. Now, an anomaly does not automatically trigger an event, okay? An anomaly needs to be now checked against a number of other things, okay? So if an anomaly has been detected before, or if there is similarity with something we've detected before, we look at whether that anomaly in the past was classified as noise or as a problem, okay? We also look at whether similar problems have been detected in the past. However, there is a threshold of similarity, okay? Again, configurable threshold. If we say if it's 80% or above similar, then we trigger an anomaly event. If it's below, we don't know yet what it is, and it still requires some additional investigation. So all those things are pretty much done automatically by SHA. And so let's do one deeper level of investigation here quickly. And so as I go into this additional level of investigation, what I see here is the topology that is involved in this anomaly. Here are things that are involved at the infrastructure level with the database, hosts, a number of other databases here, and the business services. Here is my legend to what the various icons mean. And on the bottom line, I see on a timeline, okay, things like changes, events, incidents, plan changes. So what you'll notice here is sort of this gray line, okay? This gray line is the point in time at which SHA has declared an anomaly. we'll come back to that in a second. What I notice here also is that I have a change that has occurred, okay, at 1 a.m. Okay, I have another couple of changes that occurred around 6 a.m. Okay, now what is the most common cause of problems in an IT environment? Usually it's changes, so there's a really good chance that those changes have introduced some problems. Okay, however, notice that nothing is happening for a while until about, I don't know, let's say, what's this, about 6:40 in the morning. Okay, around 6:40 in the morning, SHA is noticing that something is not right. It declares an anomaly. Okay. It takes yet another hour and a half before the first event is being generated. Okay, an event may be generated by a metric passing a threshold, but remember, SHA does not look necessarily at the threshold. It looks at normal behavior. So a metric can be out of its normal sleeve way before it actually reaches a threshold. Okay, and if we have only one anomaly, one metric out of bound, we say, okay, well, it might be noise, but it's anymore. It's most likely something that's about to happen, something that it's starting to rear its ugly head, but we don't yet know what it is. Okay, so we have basically between 6:40 in the morning when the anomaly is triggered until about 8 a.m. when the first event gets generated. Okay, notice that after events get generated, now I'm starting to get incidents. So an incident is something that we really need to now take action because things have actually triggered now into Service Manager, and a whole cascade of things are happening. Okay, so I wanted you to just get an idea of what SHA is capable of doing, how it operates, okay, and the sort of the extra time it can provide for you to be able to handle issues. The next thing I want to very quickly cover is service level management. I'm just going to give you an idea of what the new user interface looks like. Okay, so here I have already created a number of service level management agreements. In this new UI, I'm just configuring, I'm just displaying, I'm showing all the service level management that I want to look at. In this particular case, I notice that I have a critical operation for the Advantage Banking Premium SLA. I can see it at the day, week, month, and quarterly level. For the day, it looks still okay. However, all the others are currently in the red. And if I drill into it, okay, so here is why all the SLA for the day are still, the daily SLA is green because everything is still fine, okay. I can look at also all the information for the week, the month, or the quarter. However, if I also look at the historical information, I can see that on a weekly basis for the previous few weeks, I have everything failing the SLA. I have no data for the month of March. For April, I've already failed the SLA. For May, I'm still in the process of collecting, so it's not yet calculated. So this allows me now to also understand where my SLAs are failing. Okay. I'm gonna stop with it here because I just wanted you to get this quick idea of what SLAs look like in the new UI. And I want to start getting to the closure because we're getting to the end of our session. I want to give you here now a very quick sort of into the future. Where are we going from here? Okay, what's the APM and Apple's story? Remember, those of you that have been in some of the previous Vivid session, you've looked at the APM side from BPM and SiteScope perspective. Today we looked also at it from the RUM perspective, and you've also seen in the past the Apple's active, Apple's mobile, and Apple's trace, as well as the integrations between APM and Apple. So where are we going from here? Okay. We think about it from the perspective of APM is something that enables DevOps. So it is both part of development as well as part of operations. It provides a means to handle rapid delivery and changes in highly dynamic environments. We want to provide development teams insight to plan, build, and optimize the application performance, experience, and usability, and to provide the business context to development and operation. We want to share the same metrics, basically, and status. So from a priority perspective, we want to innovate and expand. We want to embed analytics into the product. We're going to increase sort of the service presence for APM. We're going to introduce the full user experience suite. And in the process of introducing the suite, we're also going to start the unification process between the on-premise and the service. Start working as one product. So in the future, we want to have this hybrid delivery model, okay, where we integrate between Apple's and APM, and Apple's also ends up also being on-premise. So if you look at it sort of like where we are today, where we're going to be next, and what's going to happen in the future, we're still looking at APM and Apple's right now in terms of APM becoming simpler and easier to use. I've shown you the new interface, a lot more modern UI. We're going to continue with that UI simplification. And then we have new user experience and the application monitoring in Apple's. Again, both of those are moving forward in terms of the integration, where at some point in the future, we want to have this hybrid analytics user experience, where both of them are fully integrated. The way to also look at it from the monitoring, the holistic monitoring strategy perspective is that we have the infrastructure, we have the practical or the synthetic monitors, we have the real user monitors, and finally we have this end-to-end transaction visibility with things like diagnostics and trace, and those act both on the IT operation side. We provide event management, alerts, dashboards, troubleshooting capabilities, and we support a variety of different applications, be those web or mobile application, SAP, Siebel, Docker, and so on. But we also want to look at it from the perspective of the application teams. Okay, so on the application teams, we want to make things a lot faster and easier. Provide self-service, user experience measurements, the client isolation, code level visibility. How does the user behavior impact the application and the development? Business insight, and provide a more agile process for fixing the problem. So we want to supply the mobile application team with the best of breed tools, and also bridge the development and operations for greater agility. Now, some of you would ask, well, do I need to choose between one and the other? And our perspective is that you don't have to choose. I mean, it depends on where your application resides, depends on what type of application you're running, and depends also on who your users are. You may go with the Apples for the application team, and you may go with the APM solution for the IT operations team, and then the two of those integrate together, whereby the APM solution brings in sort of the monitoring of the user experience, the application, and the systems for things that are on-prem and in-house, and Apples can look at things that are also much easier to use, much easier to deploy, and on demand for what sort of the applications team may need. If we look at it from the perspective of this unified suite, this is really what it looks like, okay, where you have the APM operations with the APM solution at the top here with the various monitors, diagnostics, BPM, RUM, and SiteScope. and then the application Pulse Suite, where with the its components, active mobile and browser, and coming up, and Apple's Trace, which is the end-to-end deep dive into the transaction, and where the two of them actually integrate with each other, where BPM and RUM can actually do drill downs into Trace, where Apple's Suite can actually now send data into APM and connect to APM, or APM in reverse send data to Apple's. And then we have all the integration with the external tools, where you have the operations bridge. This is basically your consolidated operations, where we send events either from APM or from Apple's. We send a topology. We can build the models with the to identify what element in the model is affected by events, and then BVD for the business value dashboard with the real-time metrics, and operations analytics with various other metrics. Finally, from the architecture perspective, it's very similar, but a little bit more sort of abstracted. Okay, on the left here you have APM and OMI. On premise, you have your application that's being monitored, and then all the various components like Apple's Trace, Active, and Mobile send data into Apple's. Users review reports and alerts from Apple's. Apple's can then also send metrics into APM, events into OMI, and then same thing for BPM, RUM, and SiteScope can generate metrics into APM, which then interacts with OMI to present events and topology. Okay, so that's in a nutshell sort of like what our view of the integration between the two of them are. And so in a summary, what we've done today is we reviewed the APM story. We looked at all the various types of monitors. We looked at the capabilities of the real user monitor and drilled into Docker. We looked at a specific troubleshooting instance of a container level application and identified the containers in trouble. We reviewed the APM predictive analytics. We looked at the new SLM interface, and we tried to provide you a quick look into the future of APM Apples. So thank you very much. There is also I believe, a survey if you want to opt in for more information. And just as a reminder that the webinar recording, the slide deck, will be posted to the Vivid website in the next few days, and you'll receive an email with the links. We have maybe a couple of minutes quick there, Rocky, if there are any questions in the room that we might be able to answer.
Yeah, thanks, Dan. Great presentation on where APM is today, and kind of a real deep dive into the suite. So a little bit longer webinar than normal, but the content, I think, if you're in the APM space, was very relevant. But I've got a few questions for you. We've been trying to answer some of these things online during your presentation, but just a few here to close out. What's the difference between BPM and RUM? They both seem to be monitoring, different network level protocols.
Okay, so in a nutshell, with BPM, we monitor actually what we think users will do. I mean, we sort of create those scripts, and it's based on what our understanding of what the users will do. RUM, on the other side, looks at what users actually do. And you'd be surprised how often users do things that we don't even expect them. I don't know about some of you guys, but we run into that all the time where users use our application in ways we never expected them to. Okay, so with real user, we can detect what people actually do, and we can then take that information, turn it back into the test environment with making more relevant tests. RUM also collects all the information at the server location, so we get all the traffic that comes into the server, while with BPM we actually position the monitors where the users are. The other thing also is, because BPM is synthetic, there are certain things you cannot do with BPMs. There are certain transactions you can't perform, you cannot move money around, you cannot do certain database commits, while with RUM you can always do it because the users are entitled to do whatever they want to. RUM runs only when, or collects data only when users are available. BPM connects data 24/7, 7 days a week, 365 days a year. It doesn't ever tire. Okay, so the two of them together provide different views into more or less the same type of information, but they basically complete the picture of each other, so to speak.
Sure. And so, yeah, the synthetic look at a potential what an end user may be like versus a real user on the system doing what they're doing. So, no, that's great. Do you have to install the RUM probe on a separate server?
Actually, you would install the RUM probe on a separate server if you're actually monitoring a physical environment. The moment you start monitoring virtual environments, the probe does not require a physical server. It actually installs on the becomes a piece of software really that monitors a virtual network. So it gets installed really in the container or on the same virtual server or in as a container in the containerized environment, and does not require actually physical connection to the networks. It does the monitoring of the virtual network and does that really on the at the software layer, whereby in a physical network you really need to connect yourself to the physical network, either to a network tap or to a span port.
Okay, great. You know, here's a question for a Service Health Analyzer. What type of data can be used?
It's a very good question. So in principle, any metric data that makes it into APM can be used for Service Health Analyzer. So anything that we can calculate baseline. So any metrics that come in on a continuous basis, we can then calculate baselines. We can calculate what's a normal behavior. And based on that normal behavior, then we can actually detect when anomalies occur and calculate whether it's a real anomaly or it's something that's just noise and we can ignore.
Okay. Dan, that's it for the questions. The remaining questions that were answered online will be on the recorded webinar when we send that to everyone, so they'll get the complete list of questions that were asked by various users as well as the answers from your team. So we are good to go there.
Okay, well, thank you everybody for listening, and we'll see you next time on our next webinar.
And from a BSM SIG perspective, we'll have an APM practitioner call here in the near future. So if you're part of the BSM SIG, you'll get that invite. If not, make sure you go to the Vivint website under chapters and SIGs and become a member of the BSM special interest group, and we'll go from there. I'm not sure if there's any other slides, Dan, but I think we're good to go here. So
no, we're done.
Everyone enjoy. Great. Thanks everyone for today's webinar, and we'll see you soon.